Okay, in this video we're going to go over section 4 of chapter 8, and we're going to look at the factored form of a quadratic. Okay, so that's our goal. So far we've looked at standard form, which can be written y equals ax squared plus bx plus c. We've looked at vertex form, which can be written y equals a times x minus h squared plus k. And now we're going to look at factored form, which would be written y equals a times x plus x1 and then x plus x2. All right, so all of these forms have one thing in common. They all have this a. This a is the same no matter which form we look at. The a indicates whether we have a vertical stretch or a compression, and if it's a negative in front of the a, it tells us that it is flipped over the x-axis, so it is facing down or concave. If there's a positive in front of the a, it's concave up or facing up. So if there is a positive, your vertex will be at a minimum. If there's a negative, your vertex will be at a maximum. Okay, we're going to focus on the factoring form of things, and this gives you another little exercise that you could do. So here is our standard form, but notice that they've highlighted the a, b, and c because they're going to be instrumental in what we do next. Okay, a little definition. To factor a quadratic is to find out what two things or two factors multiply to get that quadratic back. It's called factoring because we find the factors. A factor is something we multiply by. So, for example, if I said y equaled a times x minus 2 times x plus 4, these would be our factors. Okay? They are what we multiply together in order to get the standard form back. Okay, let's move on to our next slide. Okay, in this slide, the example that's right here shows how to multiply factors together. So there, and the goal is to get the standard form back. What they are doing is a process called expansions. They're expanding it. When you expand your factors, you get back the standard form. When you factor your standard form, you get back your factors. Okay, so be able to discern whether you're expanding or factoring and use the right terminology. Now, they are factoring using a method called distribution, okay, which is a totally fine method, and you certainly may use this method. So let me tell you how they did this. So they started out looking at this factor, and they said, let's take the x, and we're going to multiply it by this x. Then we're going to multiply it by a negative 1. Okay, that's the setup. Then let me change colors. Then what's going to happen next is they're going to take the 4, and they're going to, they're going to take the 4 and multiply by the same two factors. And then they're going to add both of those together. Okay, so here's the 4 times the x minus 1. So when they do that, they distribute the x to both terms in the second factor. They then they use the addition from the 4 right here. That's the addition that they're talking about. Then they multiply the 4, which is the second term in the first factor, times the entire second factor. Once they have done that, their next step is going to be to combine like terms. These are like terms. They both have x attached to them. So combining like terms gets you the 3x. Your other two terms come from the x squared, which you just bring down, And then the last one is the -4, which you also just bring down. So that got us right back to our original standard form. Okay, so that's one method of multiplying your factors. There is another method, and that method is called FOIL, or foiling. It's an acronym, so we're going to do each of the words attached to the letters of FOIL. Start out again with your same two factors, because we want to get back the same exact quadratic. And so what I'm going to do first is the F. So when I do the letter F, which is first, I'm going to say my first term times my first term here. So that will give me x squared. X times x is x squared. So we'll change colors, and then we're going to do our outers. Okay, the outer is the x times the -1. Notice that the sign comes along with it. So an x times a -1 gives me a -x. Next, we're going to do the inners. Both have signs attached to them. A +4 times an x, a positive x, it's going to give me a +4x. Okay, and then we're going to do our last. And I really should say that both of these have signs attached to them. A +4 times a -1 is a -4. So now let's see what we have. Combine our like terms, just like we did with the distribution method. That gives us a +3x. And then just bring down your other two terms, which is x squared and the -4. And there you have it. So whether you FOIL or distribute, you will get the exact same quadratic function back. Okay? You may use either method in our class. Okay, let's go on to the next page. Okay, this page is worth talking about for a second because they are showing us the difference between expanding and factoring. So expanding gets you back your quadratic in standard form. Okay, in standard form. When you factor, you get your factors, these two factors that make up our quadratic. So expanding is going this way, and factoring is going this way. Many people will confuse those two terms, so make sure that you are clear on that. And then they say wise words down here. Expanding is usually easy. Okay? Yep, it usually is. But factoring can be a little trickier. But we're going to teach you some good strategies for doing that. Okay, there are several strategies they're going to go over. And the first of which is factoring out the common factor. Now, you can use this and just be done if you only have two terms. Or you can use it and be starting another strategy. So we'll talk about common factor factoring on the next page. Okay, I have found that common factor factoring, or as it's frequently called, greatest common factor factoring, is the most neglected and confused form of factoring that we have. Okay, you always want to be on the lookout for common factors because it'll make your life easier. So, I do it this way. Okay, I would never stop at this step. Okay, so don't do this. When you are going to try to find your common factor and you have numbers and variables, I agree with this. Okay, so this is the first thing you look for right there. Just don't go to this step. Look for this and say, what do they have in common? There's a 6 and a 2, so they have a 2 in common. But then don't stop there. Then say, okay, besides numbers, we have variables. So what variable do they have in common? And then your answer should be they have an x in common. So your common factor is a 2x. Factor out a 2x, and then say to yourself, okay, I've pulled out a 2x. I need to get back this original equation. Put a paren and say to yourself, what do I put in this first location so that when I multiply the common factor of 2x times something, I get this back? And the answer is a 3x. Next step, write down that operation, put it right there. Then look at your last term. Okay, your last term is the 2x. You have a 2x. You need the 2x back. What do you put here to ensure that you have that? And the answer is a 1. Okay, that 1 is confusing to lots of people. So just be clear that you need that there almost like a placeholder so that you can distribute the 2x to it so that you are getting this quadratic back again. Okay, so now we have factors. Okay, what are our factors? The factors are each term that has an x in it. So your factors are 2x from the front and the factor in parentheses. So it does not have to have a paren around it to be a factor. The deciding point is if it has an x in it, it is a factor. So you have two factors, 2x, 3x minus 1. Okay, we're going to use these factors to get our roots. Set each factor to 0, and that's what they're doing there. Okay, so I have 2x times 3x minus 1. If I set 2x equal to 0, the only place that's going to happen is if x equals 0, and there we go, that's my root. Then look at the second factor. The second factor is 3x minus 1. Set that equal to 0. So bring the 1 over, so I get 3x equals 1. Divide by 3, divide by 3, and that will equal 0, where x equals 1/3, which gives us our second factor. Okay, so setting your factors equal to 0 give you the roots, or the zeros as they're frequently called, of the quadratic equation that you're working with. Okay, let's talk about another strategy. Okay, so in this strategy, it's called factoring by decomposition. So decomposition is our mission. Okay, the book calls this the AC method. Okay, that's because you're going to multiply your A and your C together, and you're going to say to yourself, what two numbers multiply to AC and add to B? The numbers that you pick, you're going to use to decompose your middle term. Okay, so let me run this through. So you see they have it written out like this. Let me just do it my way and then see if that makes sense to you. So I'm going to set it up over here. I'm going to say we have 2x squared plus 7x plus 3. So I want to look for two numbers that multiply to 6 and add to 7. So decomposition is our mission, and I'm going to decompose the middle term. So that's the linear term. So what two numbers multiply to 6 and add to 7? 6 and 1 would be our bingo. So we're now going to break up our 3 terms into 4 terms, which, believe it or not, is easier to factor. So I have 2x squared. Now break up the 7x into positive 6x and positive 1x. And then you still have your plus 3. So here was our decomposition. Do you see how I didn't change anything? Because if I add those two together, I'll get the 7x back. So I haven't changed my factor. I haven't changed my quadratic at all. I've only changed the way it looks. Okay, so I'm going to write this in one solid color. So we have 2x squared plus 6x plus 1x plus 3. 4 terms. Look at the first 2 terms. This is the greatest common factoring piece of it. So what do those 2 terms have in common? And you should be looking at the numbers, which is 2, and the variables, which is x. So they have a 2x in common. Here comes your paren. To get the 2x squared back, I need an x. Follow the x with the plus sign from here, and then say to yourself, I have a 2x, I need a 6x. What goes here? And the answer is a 3. Okay, so then I'm going to bring down this operation. That's going to go right there. I'm going to make parentheses here, and in the parentheses, I am going to put the exact same thing. Then I'm going to say to myself, okay, my second term is a 1x plus 3. I have a 1x plus 3 here. I need a 1 here. Now I'm ready to get my factors going. Okay, my 2 factors are what you see that's already in parens, which is x plus 3, and then what you have not touched, 2x plus 1. Those are your factors, and if you FOIL them or distribute them, you will get your original function, which was 2x squared plus 7x plus 3 back. But those are your factors. So now what are our roots? Our roots are x plus 3. Our roots happen where x plus 3 equals 0. So therefore x equals negative 3. And the other one is 2x plus 1 equals 0. So 2x equals negative 1. X equals negative 1/2. Okay, so what do I think this quadratic looks like? Based on what I've just discovered, let's see what I know. Well, I know that this is the y-intercept. 1, 2, 3. There's my y-intercept. I now also know that I have 2 roots. One is at negative 3. 1, 2, 3, right there. Whoops, sorry. Right there. And the other one is at is at negative 1/2. Okay, so that's interesting. So let's put that right here. Can I get it right here? So all I know right now, without thinking about the vertex, is that this particular quadratic looks like this, and I'm not sure, because I haven't analyzed it, where that vertex is. But I now know my roots and my my y-intercept just looking at the c in the original equation. Because we already know how to get the x value for the vertex as well as the y value, we could easily solve for that as well and have a complete picture, but I'm not going to do that at this point in this problem. Okay, notice that they are following different steps, so they've elongated their steps, so you certainly should read through this, but I have shown you how to do decomposition. And my steps work as well. They're just a compressed form of what the textbook has done for us. Okay, let me just say a word about their step 4. Notice that they have gotten down to the same factors that we had, and they have not gone through to set the factors equal to 0. But when we did that, remember how we did that, and we got the first one. Your x is going to be negative 1/2, and the second one is x equals negative 3. Now, they have a little caveat here, and I would totally agree with this caveat. When your a is a positive 1, you do not need to do the decomposition of the middle term. However, doing it will always get you the right answer. So if you want to have one method, this is the one method that you can always use if you're able to factor. Okay, because not every quadratic is going to be able to be factorable, but if it is, this method of decomposition will always work. The easier method happens when your leading coefficient right here, your a, is a positive 1. When that happens, instead of decomposing, you can go right to your factors. So this is what we do. Okay, here I say, all right, I see that my leading coefficient is 1. So I'm still going to say to myself, what multiplies to 6 times 1, which is 6. So what multiplies to 6 and adds to a negative 5. Okay, so multiplies to 6 and adds to a negative 5. So that's going to be a negative 3 and a negative 2. Okay, so therefore you can go right to factors. Put in your negative 3, put in your negative 2, FOIL it to check. It should verify that you get back x squared minus 5x plus 6, and then set those equal to 0 to get your roots. And your roots this time are going to be x equals 3 and x equals 2. So what does this look like? Well, let's see. Here's my little grid. Here's the 6 for my y-intercept, and then my roots are here and here. This tells me that this quadratic has to go through these two roots. If I say that this is 2 and this is 3, and it has to go through the 6. I also could have figured out this, but we're not doing that right now. Okay, so they're going to have us figure out another simple one in just a sec. So let's do that on the next page. Okay, so let's try this simple one here. Now, I noticed that my a is 1, so therefore I don't have to do decomposition. So let's just go ahead and figure out the question I always ask myself. What multiplies to a positive 63 times 1, which is 63, and we always say adds, and adds to a positive 16. Okay, I'm getting 9 and 7. We'll do that. They'll multiply to 63 and they will add to 16. So look what I can do. If I want to go right into factoring, I can say, okay, my factors are minus 9, or 9 and 7. Okay, so if I were to FOIL that, I would get x squared plus 7x plus 9x plus 63, which is x squared plus 16x plus 63. So I'm good. And my factors tell me that my roots are x equals negative 9, set the factors equal to 0 and solve, and x equals negative 7. So why don't we prove to ourselves that we could have done the longer way of decomposition? So we'll do that in a different color. So when I got the 9 and 7, I could have done the following. I could have said, okay, so x squared plus 9x plus 7x plus 63 are my 4 terms. Look at the first pair. What do they have in common? Just an x. So I factor out the x, and I put x plus 9 inside to get back the underlined expression. Bring down that operation, make this match, figure out what goes here to give us back this. Well, I know I have to get a 7x, so I can only put a 7 there. So I'm one step closer to getting our factors. I can already see the x plus 9 factor. Then look at the x plus 7 factor. Okay? We got the same factors that we got in the shorter method. So know that decomposition will always work. And we're still getting x equals negative 9 and x equals negative 7 for our two answers. Okay, what does this mean about our quadratic? So let's give ourselves a quick little sketch. Okay, so let's say this is a little bit not to scale, but let's say that that was 63. And then I have a negative 9 and a negative 7. So let's say I have one of negative 7 here and a negative 9 here. So I know so far my parabola will look like that. And the vertex is as yet to be determined. But at least I have a sense of this quadratic, which is mainly on the left side of the y-axis. Okay, let's go on to the next page, and I believe they're going to have us try another decomposition. And in this case, your leading coefficient will be a 2. Okay, so we're going to try this, factoring this quadratic by decomposition. So I say to myself, what multiplies to a negative, notice why it's negative, a negative 24, because I've got a negative right here, okay, and adds, because we always say adds, to a positive 5. Okay, so my thought is it's going to be a negative 8 and a positive 3. Okay, so we're going to decompose. So if I initially had y equals 2x squared plus 5x minus 12, then if I decompose the middle term, I'll have 2x squared minus, no, so I'm sorry, it's the other way around, plus 3, I lost my head there, and let me just erase that, and a negative 3. Okay, so glad we caught that early on. Okay, so it's going to be, why don't we just say plus 8x minus 3x minus 12. Now at this point, you want to check to make sure that this gives you back your linear term. So I would have caught the mistake there, so always do this step because you can't change a quadratic. Okay, so I see that, yes, a positive 8x and a negative 3x gives me back a 5x. So now we're ready to do our factoring. So I'm going to write this over so that I can underline what I want to underline. Now, the order here doesn't matter as long as your signs are correct. So don't think, oh, I always have to have the bigger one first or the smaller one second. It doesn't matter. It'll all work out. So now look at our first pair. And the first pair has a 2x in common. In order to get this first pair back, I have to multiply the 2x by x. That gives me 2x squared. Bring down your addition, and then multiply the 2x by 4, and that gets me the 8x back. Okay, this is key. Bring down that operation. Give yourself a space, and match the x plus 4. Then say to yourself, what goes here in order to get a negative 3x minus 12 back? Well, I already have the negative in front of the 3 right here by bringing down the operation. If I put a negative here, I will indeed multiply to a negative 3 minus 12. So I know that those are correct. Now, what are my factors? I always pick the one that I can readily see because it's already in parens for me. And then the other numbers that are not in parens make up your other factor. So you can always, FOIL it out and check to make sure you're good. So x times 2x gives me 2x squared plus, plus a negative 3x. So negative 3x plus a positive 8x gives me a positive 5x. And then a positive 4 times a negative 3 gives me a negative 12. So my factoring checks out because I can FOIL it back to the original function. Now I want to know what are the roots. So the roots will be x equals -4. I got that by setting the first factor equal to 0. And then let me do this one because it has a couple of different terms. Set this one equal to 0 as well. First step is to bring over the number. Second step is to divide. So always bring your constant over first. And then you're going to have 3/2 for the other root. Okay, so here are our two roots. 3/2, aka 1.5, and -4. And we can figure out what this looks like as well. So let's see what's going on here. So we're going to have roots up here. This is going to be the -12. Okay, then I'm going to have a root at -4 right there. Whoopsies. Right there. And then the other one is at 1.5, which will be right there. So this quadratic looks something like that. And again, we can still figure out the vertex, but we're not doing that yet. Okay, let's go on to the next page and see what they have in store for us. So here's another example where you have some more choices to make. So I can see that I have to do decomposition because my leading coefficient right there is a 6. So I have no choice but to do greatest common factor factoring. And what else do I think about? I think, could I have done some greatest common factoring to get me started? And no, I can't, because 6, 5, and 6 only have 1 in common. So that's not going to help me. So then I say, and we'll follow these steps, what multiplies to a -36 and adds to 5. So if you list out all the numbers, these are the positive factors that multiply out to a -36. We want to figure out which ones will add to a 5. Now the signs will be different, right? Because in order to get a negative answer, you're going to have a positive times a negative. That's the only way to get a negative. So, and then looking at your middle term, I see that the bigger number has to be positive. So I agree that 9 and -4 work nicely. So now what they're going to do is they're going to decompose that middle term, which used to be a +5. Okay, so I initially had 6x squared plus 5x minus 6, and I decomposed the 5x into a -4x plus 9x, and you see how that would add back to the 5x? So I'm not doing anything that upsets the apple cart here. Okay, so I'm going to do this the way I teach it. So I'm going to write this here, and I'm going to say, okay, looking only here, what do they have in common? And the answer is a 2 and an x. And then to get that expression back, the 6x squared minus 4x, I need a 3x minus 2. Bring down that operation. That is key. Okay, a lot of my kids will have another paren right next to it, and they'll be into multiplication, and that's not correct. So give yourself a space. Here's your space. And then you have another 3x minus 2 because they have to be twins. Okay, so what goes where the blank line is? Well, to get a positive 9x, I need to have a 3. So here my factors are. Grab the one that you can see readily. The order does not matter. And then grab whatever's left, and you have your factors, and you could check if that works. But you want to definitely always check that it works. Make sure when you FOIL it, or whether you do the foiling or just the multiplication by distribution, you need to get back 6x squared plus 5x minus 6. Doing that step is essential because you will catch a mistake. Okay, let's get our roots. So set each factor to 0, and you have 3x equals 2. or x equals 2/3. That's our first root. And the other one, 2x plus 3 equals 0. So 2x equals -3. X equals -3/2. All right, there are our two roots, our two zeros of the function, our two places where our parabola crosses the x-axis. So let's do strategy 3 on the next slide. Okay, so they say that another way you can find your roots is by graphing, but I would totally agree with them that you have to be very, very careful. Okay, so if you look at this and you already know that your function is 6x squared plus 5x minus 6, if you look at these roots, you can kind of guess where they are. I mean, this one is good. That's your -3/2. This one, not so much. That's going to be pretty tough to guess that that's 2/3. So for this particular example, it's not very easy to guess. Although it's always worth, looking. If you're stuck on factoring, you can certainly look at your graph. I would say that you are more apt to be able to use this method when you have nice clean roots, meaning that they're whole numbers. So those you can easily spot. But even then, I would still multiply it out to make sure you get back your exact, correct quadratic function. Okay, let's go on to the next page. They're going to hit upon strategy 4, which is using the quadratic equation. That method always works for factoring. Well, I take that back. It always works for finding your roots, because sometimes you don't have real roots, so you're not going to be able to factor. But we'll talk about that in just a second. Okay, so strategy number 4, using the quadratic equation, because either you can't find the multiples that you need, or because not all quadratics are factorable. So there's a general solution, and it's useful when the above method fails, or whether it's taking you too long to do the above method, and that uses the quadratic formula. Now, a key thing to memorize this is, you would say x equals -b plus and minus the square root of b squared minus 4ac all over 2a. That part is key. It's all over 2a. Now, what are these a, b's, and c's? Well, they are the a, b's, and c's that you get from your standard form. So it goes on to say, use that formula to get the two answers, x, both x, the plus and the minus of x. One is the plus case and the other is the minus case in the plus and minus. And we get this factoring that way. So let us use the previous example to see how this works. Okay, so let's run through this. So I am not, well, maybe I'll go to the next page and run it through with them. So hang on, we'll go to the next page. Okay, so here we go. So first off, you definitely want to recognize what's your A. There's your A. Here is your B. It includes the sign. Here is your C. It includes the sign. So be careful about that. That's number one mistake we could make. A is positive, B is positive, C is not. Okay, so let's say that we could not get our roots, or we just wanted to check to make sure we're correct by using the quadratic formula. So x equals -b, so you would put in -5 here, plus and minus. That means you're going to do two equations with this. The square root, I'm just going to continue their square root symbol, of b squared, that's 5 squared. Now notice, an important thing. If b was negative, so let's say it was -5, I would have written it -5 squared. That is key, because you will always, always, always get a positive term right here. Okay, so be careful with that. And then minus 4ac. Notice how they put that in parentheses because they wanted to capture the negative. That negative is going to flip that sign. So see how right down here we had 25 and then now it's plus. This whole product because of that negative in front of the 6. So the negative was key. So I have negative 5 plus and minus the square root of 25 plus 144 over 12. Okay, so here we go. So I have 25 and 144 gives me 169, which is a perfect square. So that gives me 13. Now, this is how we get our answer. You have negative 5 plus 13 all over 12. That's one answer. What is that? That's going to be what? Negative 5 plus 12 is 8. So this is 8 over 12, which reduces to 2 over 3, which was one of our roots. Then our second answer, going back to the original result of our quadratic equation, is negative 5 minus 13 over 12. So that is negative 18 over 12. And what goes into both of these? So let's see, I would say a 9. So, I would say a 2. So that's negative 9 over 6. We can go further, right? So we could have said a 6. So let's say a 6, and we'll get there quicker. Okay, a 6 goes into that negative 3 times over 2. And here is our other root. So you see how you can get the exact same roots when you use the quadratic formula as when you use your factoring. Okay? But the quadratic formula is the only thing you can do if your quadratic is not factorable. Okay? So that quadratic formula comes in very, very handy. Okay, let's go on to the next page. Okay, on this page, we're going to do some factoring practices. So if they give you answers, we can just check our answers and see what we think. Okay, so looking at all of these, if we FOIL them, I will always get 6x squared back. So each one of these gives me a 6x squared. So I checked that first, and I can't eliminate anything. So now let's go to the back. How about if you say 2 times a negative 1? Okay, that gives me a negative 2, so that works. Negative 2 times 1 gives me a negative 2. Oh, look at this. Every single one gives me a negative 2. Okay, so they're going to really make us work for this. So do your middle terms. If you have a 12, so I'm looking at A, 6x times 2, so I'm doing the outer and the inner. So 6x times 2 is 12x, and then a negative 1, that's going to give me a positive 12, which doesn't work. Okay, so let's do another one. So how about, let's go B. Okay, so that's going to give me a negative 12x and a positive 1x, which will give me a negative 11x. Doesn't work either, so that's out. Okay, so C. So C is going to give me a positive 3x and a minus 4x, which gives me a minus x, which is close but doesn't work. So hopefully this next one will work. This is a 3, positive 3x, and that's a this is a negative 3x, and that's a positive 4x. If I do my outer and inner, that gives me a positive 1x, which is bingo. So that's how I got a D. So I could have just gone ahead and factored it, but if they give you numbers, you might as well go ahead and use what they gave you. Okay, so if we did the same method for the next one, and I'm seeing that my first term is a 6x squared in every case. My last term is a positive 77 in every case. So once again, I've got to go for the middle terms. So I have 2x times 11x to do the outers is going to be 22x. The inners will be 21x, and that's not going to work because they're both positive, so that's no. Okay, this next one, I have 33x, which is positive, and a 14x, which is positive, but does not get me what I needed, so no, that's out. Okay, the B is, let's see, 22x, which is negative, and then a negative 21x, and that's not going to do it either, so that's out. So once again, we're hoping for D. That's a negative 33x and a negative 14x, which does indeed add up to a negative 47x, so that's it. Okay, so we didn't guess, we worked it out after we first observed that the middle terms and the last terms all made up our A's and C's for the quadratic, so that all worked great, but the deciding factor was the numbers that multiplied to the middle term. Okay, so that's how you would do it, given a multiple choice, or you can just go ahead and factor it directly and then find the answer. Okay, let's move on to the next page. Okay, so for these, we're going to actually do the work. Sorry, let me go back to my right page. Okay, so we're going to actually do this work. So we are going to say, let's see if we can figure out about this. I can't do greatest common factor factoring, and I have a leading coefficient that's not 1, so I'm going to do decomposition. And since they've given me the roots, I'm going to just figure out what the roots are by taking my factors that I solve for and setting them equal to 0. So I'm going to say what multiplies to positive 40 and adds to a negative 13. Okay, so let's think about that for a second. Okay, so what do we think? And I am thinking negative 8 and negative 5. What do you think about that? Negative 8 and negative 5 will certainly multiply to a positive 40, and they will add up to 13, so that's going to work. So let's see what I get. So that's my decomposition. So I'm going to say, so we have 20x squared, minus 8x minus another 5x plus 2. Okay, decomposition is our mission. Get your first pair. So what do they have in common? It looks like a 4x, and then on the inside would be 5x minus 2. Make this happen, 5x minus 2. Bring down that operation, and it looks like if I put a 1 here, that's going to work. So my factors appear to be 4x minus 1 and 5x minus 2. Now, I took the numbers that weren't in parens first in that time, so it doesn't matter your order. So what are my roots? 1/4, which is equivalent to 0.25, because I noticed that they have decimals. And the other one is 2/5, which is equivalent to 0.4. They are both positive. So let's see what we have. So it looks to me, since they're both positive, B is our answer. Okay? Okay, we have one more here. So, again, they gave us the factors, so we could play with this. I'm just looking quickly. And, of course, the first term and the last term work out great. So, why don't we just go ahead and we'll factor this instead of going through all the examples, because it may actually be quicker. So, what does this say to us? What multiplies to a negative, what is that? 8 times 5 is 40. Put down the 0, carry the 1. 8 times 1 is 8. And 4 more is 12. So what multiplies to a negative 120 and adds to a negative 2. Okay, so think about that for a second. Okay, so hold the phone. Let me just make this correction. So I've lost my head. Okay. Let me just see. Okay, so I was right. I lost my head there for a second. Okay, so what's going to do that? Well, an obvious thing is a 12 and a 10. So what do we have to do with our signs to make that happen? So the 12 has to be negative and the 10 has to be positive. So that'll give me back a negative 2. Okay, so we have 8y squared minus 12y. Now don't get thrown off by the y, it's okay. Plus 10y minus 15. Okay, so here we go. What do they have in common? 4y. And then to get that back, I'm going to have a 2y minus 3. Bring down the positive. Make this happen. 2y minus 3. It looks like if I put a 5 here, that's going to work. So I have 4y plus 5 and 2y minus 3. So do I have that somewhere? 4y plus 5, 2y minus 3, bingo, right here. Okay, so that's 4 example problems, and there are more to come. Let's go to the next page. Okay, so we're going to do some of these problems. Now, the first thing to notice is that you are not set equal to 0. So you need to bring this guy over to the other side. When you do that, you get x squared minus 11x plus 24, set it equal to 0 to factor. Okay, so this is easier factoring, so I can not have to do decomposition. What multiplies to 24 and adds to 11. So 8 and 3 will do it, provided they're both negative. Those are our factors, and here are our roots. Okay, so that's not too bad. Pause this whenever you want to and see if you can do this yourself. So again, bring this over. So I end up getting n squared plus 7n. I bring over minus 5. I have a plus 10. So that's going to be n plus 5, because 5 and 2 are going to do it. And n, sorry, I'm just thinking about x's, and I have to fix this too. So remember, you can have any variable, but just be consistent. That equals 0 over here. Okay, so this is n plus 2. So do it in your head to make sure you're seeing you're getting the right answer. And then our two roots are negative 5 and negative 2, setting those equal to 0. Okay, so next one, let me see how I want to do this. This is going to be hard factoring, or decomposition is a must because I have a 6 there. So let's see where I get to first, because actually I think I'm going to try greatest common factoring before I do anything else. So subtract 6 from both sides. That's going to give us 6n squared minus 18n, and then minus a 24. Okay, they all have something in common, so don't rush to factoring. Okay, 6 can come out. That gives me n squared minus 3n minus 4. Okay, so keep your 6 out here. It is not a factor. There is no variable there. Then factor the inside. So it multiplies to a negative 4 and adds to a negative 3. And that's going to be negative 4 and positive 1. So my factors will be n equals 4 and n equals negative 1. Okay, so that was a tricky one. If you had overlooked the greatest common factor factoring, you would have had to do decomposition, which is not bad, but it would have taken you a little longer to get that problem accomplished. Okay, so let's do the next one. Once again, bring the 6 in. So when you do that, you subtract 6 from both sides, and you get n squared plus 3n minus 18. Again, this is not, you don't need to do decomposition for this. What multiplies to a negative 18 and adds to 3, and it's going to be 6 and 3 with the 6 being positive. So I'm going to have n minus 3 n plus 6. Again, FOIL it to make sure we are correct. And we're getting n equals 3 and n equals a negative 6 for my roots. Okay, let's go on and we'll do some more on the next page. Okay, we have 2 more factoring, and then we have a quadratic to solve. Okay, so let's look at 5, and bringing the negative 2 over makes it a positive 2, so we're getting n squared minus 10n plus 24. So what multiplies to 24 and adds to a negative 10, so that's going to be negative 6, negative 4, x equals 6, x equals 4 are our roots or our zeros of the problem. Okay, so now let's look at this one. Again, we want to have everything on one side. So we have 7r squared minus 14r plus 7 equals 0. Okay, now don't neglect greatest common factor factoring. Factor out that 7. And you're going to get r squared minus 2r plus 1. And 7 stays on the outside. What multiplies to positive 1 and adds to negative 2. So that's going to be r minus 1 times another r minus 1. And we have what's called a double root. So our roots are r equals 1 and then another r equals 1. Okay, so this is kind of a curious situation. It's a very interesting situation. We have this answer. If your r is 1, we're right here, and your c is 7, we'll say that's there. This parabola sits right on the x-axis at 1. And this is called a double root when the vertex is resting right on the x-axis. Okay, so that's kind of an interesting situation. Okay, let's do a quadratic formula. Let's just refresh as to what it is. Negative b plus and minus the square root of b squared minus 4ac all over 2a. Okay, clean this up. 3x squared plus 20x plus 32. Do you see why? Okay, if they want to do quadratic formula for this, we have to just define our a's, b's, and c's. A is 3, b is 20, and c is 32. Okay, so let's set up our problem. Negative b, so that's negative 20 plus and minus b squared, which is going to be 400. All right, 20 times 20, 400. And then you have minus 4ac, so minus 4 times 3 times 32 is going to give me a negative 384 all over 2a, which will be 6. So, what are our answers? Well, 400 minus 364 gives me a 16 under the radical. That's a perfect square, so I'm going to bring that out as a 4. So I have negative 20 plus and minus 4 all over 6. Let's do the top first, which means the positive. So negative 20 plus 4 over 6. That's going to give me negative 16 over 6, which can be reduced to negative 8 over 3, and that is one of our roots. Okay, let's go to the bottom now. Negative 20 minus 4 over 6, so that's negative 24 over 6, which is going to give me a root of negative 4. So I have one whole number and one fraction. those are my two roots, and I solved that by quadratic formula. Okay, so we've had a lot of practice on this. Go back and go over whatever you need to. Get good at factoring. Get comfortable with it because it's a wonderful technique, and many people need help with it, so be the helper.